plans for this week? All right. 3-8 go over. 3-9 learn. 3-9 go over. 3-10 review. All right, friends, take a look at the boards. One or the other. So today we'll finish up 3-8. We'll learn 3-9. Tomorrow we'll go over 3-9. We'll have you start the review for 3-10. We'll go over 3-10 Wednesday. We'll do a test on chapter 3 Thursday, and we'll get everything prepared for our final come Friday. So, what is special about this Friday other than it being the last Friday of the semester? Yeah, anything you owe me, any homeworks, any tests, they're due by the end of the day that Friday. Actually, I'm not available during 8th period on Thursday and Friday. So please, 8th period, I can't help because I have the boys basketball tournament. I have to make sure being the first game starts at 3:30. No, it starts Thursday and Friday. Being the first game, it starts at 3:30. I got to leave, make sure I'm over there 8th period to get the gym set up and ready for a 3:30 tip-off. I kid you not. Originally, it was a 3 o'clock tip-off, and it's like, Mr. Wilkins, we have class until 3:30. Yeah. Yeah, Varsity Holiday Classic, I think it's called. All right. Here we go. So, this talks about the weight of apples, normal distribution. So we have a mean of 85 grams and a standard deviation of 12. Okay, what percentage will be greater than 100 grams? I'm sorry. Page 191. Page 191. All right. So this is a Desmos problem for sure. You guys are all chatty today. So let me log on to this. Bust out our buddy Desmos. Someone asked the other day, are we allowed to use Desmos on the final? All right. So normal distribution. So we have a mean of 85, and we have a standard deviation of 12. So you hit the plus. It'll show you your normal distribution. So greater than 100. So I want the area to the right. So 100. So 10.56% of these apples weigh more than the 100 grams. And then it says, you buy 2 apples. What is the percentage that the pairs of apples will weigh between 155 and 180? Hey there. All right, so being that we're buying 2 apples, we are doubling. All right, so problem number 2, if we're buying 2 apples, means I multiply by 2 the mean and the standard deviation. Okay, so if the mean was originally it was 85, we're going to go 85 times 2. And if the standard deviation was 12, we're going to multiply that by 2. And then we want, so that's what we're plugging in, so 85 times 2, and Now, something I think I might work on Desmos. If I go 85 times 2, and then comma, I want to see if this works. And then 12 times 2. I just want to see if this works. I think it should work. Yes, it did. All right, good. All right, so notice I went 85 times 2 and 12 times 2 because I'm doubling the amount of apples. Doubling means multiply by 2. So now we want to know, of our 2 apples, what's the probability that we will fall between 155 grams for both apples and 180 grams for both apples. So that's that region. So, oh, wait. Did I do that right? 155, 180. Oh, dude. I screwed up the standard deviation, didn't I? Standard deviation, I goofed up. So what I have to do here is, in order to find the standard deviation of this, I have to go 12 squared plus 12 squared. So that's 144 plus 144. So that's going to be root 140 or root 288. So notice what I'm going to do here. I'm going to change this. It wasn't times 2 for the standard deviation. I have to do the square root of 288. And that works for us. Oh, that was my big mistake. So remember, when you're doubling, the standard deviation doesn't get multiplied by a factor of 2. You have to do the square of the standard deviation plus the square of the standard deviation, and whatever that sum is, take the square root of it, which would have been 288. So we're talking about 53.38% of my apples would be above. For each of the following questions pertain to 6 apples, assume the bag weighs essentially nothing. So the mean and standard deviation for that. Okay. So for problem number 3, our mean is going to be 85 times 6. So what was that? 30, carry the 3, 48, 510. That's going to be the mean that we're going to use. In order to find the standard deviation, I need to do root 12 squared plus 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 12 squared. Or that could be written like this, 6 times 12 squared, and it should handle our order of operations. And again, on Desmos, if you plug that directly in, so being I'm doing 6 apples, I'm going to multiply that by 6. If I do underneath here, I think I can go, oh, shoot, I can go square root of 6 times our standard deviation of 12 squared. Okay, so if I click that, that changes our normal distribution to that. And then what is, so our, if I go 85 times 6, I get 510, which I got. And if I do this math here, this is actually going to give me 29.4. Okay, so that's what A would be. The answer for A is, that is the mean, that is the standard deviation. If you buy a bag of 6 apples that weigh in the 90th percentile, how much of this group, how much does this group of apples weigh? All right, so if I want to find the 90th percentile, remember I have to go dot inverse CDF, and I'm going to plug in 90th percentile, so 0.90. Oops. And that shouldn't have been a comma. That should have been a period. I'm sorry. Monday morning jitters, I guess. So that would mean that if you had 6 apples that were in the 90th percentile, that means that the apple, those 6 apples would weigh 547.68 grams or 6, 7 grams. 6, 7 grams, okay. And then what percentage of the apples will be less than the 500? So I have to get rid of the inverse CDF, bring back my normal distribution. I want way less than that, so this needs to be negative infinity. And less than 500. So you would talk about 36.69% of the apples would weigh less than of that bag of apples would weigh less than 500. And a bag of apples are rejected if they don't weigh between 470 and 530. So if we had a group of apples, a bag of apples that weighed, between 470 and 530. So that would mean that 66.5% of the apples, if we had a bag of apples, there were 6 of them in there, weighed between that, we would reject it. And then, make sure I'm on the right one. What are the following race times provided? All right. Following race times is on page 192. The following race times are track and field runners in a specific race. Provide the calculator commands for the bell curve, but not the bell curves. Okay. What is the probability Isaac will obtain a time less than 57 seconds in the next race? Okay, so we are just worried about Isaac's information. So Isaac was 57.4 seconds. 57.4 seconds, comma, and Isaac has a standard deviation of 2.4. We want to know what's the probability he gets less than that. So I'm going to go negative infinity. And I'm going to go 57 seconds. And so it looks like 43.4% of the time, Isaac will be less than. What is the probability Isaac and Renee will combine a time for less than 103 seconds? Okay, so what I can do is this. Isaac times Renee. Renee is 56.2. So notice I'm plugging in the math calculation into it, and then for the standard deviation, I'm going to do the square root of each of their standard deviations squared. So 2.4 squared. 2.4 squared plus 2.1 squared. All right. Oh, wait. Okay. There was an error there. 56.2 and 57.4. All right, there we go. We made it right. All right, so if I do this, that's their normal distribution. What's the probability they get less than 103 seconds between them? What did I do wrong? I thought I did it right. 57.4 times 56.2, comma, square root of 2.4 squared plus 2.1 squared. I do have to add them. Oh my gosh. Plus, thank you. There we go. So it doesn't even show up on the normal curve when I add them. Hang on, that shouldn't be happening. Oh. So, what did I do wrong? 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 Who sees my error? 10,000 extra credit points. You see my error. That's sarcasm. 3.8. I forgot. I did something wrong. Chapter 3. Review. Can't take me anywhere. 3.8. That doesn't make sense. What did I do goof up on? Okay, made an error. I made a mistake here. So I got to see what this comes out to. I think it might be just too much for the calculator to handle like this. Squared plus 2.1 squared. So that should have been 3.8. 3.19. I made a mistake. I don't know where my mistake is. Anyone? 3 seconds. It shouldn't be happening. $57.4 plus 56.2. It's 113. Oh, it actually is right. Okay, it works. Because if I took my math, if I went 113.6, think about how many standard deviations. 3.19 minus 3.19 minus 3.19. So we are more than 3 standard deviations below the mean. So that score is actually good. So they have a very unlikely probability that the two of them combined run below the 103 seconds because it's more. So what is the mean and standard deviation of the entire race team? Okay, so I can just get rid of this. So the entire race team. So I'm going to go 57.4 plus 56.2 plus 58.4 plus 57. So the entire mean of the team is that. The entire standard deviation, if I do the square root of this, I'm going to go 2.4 squared plus 2.1 squared plus 2.5 squared plus 2.3 squared. All right, so the entire team would have a mean of 229. The standard deviation of the entire team would be 4.66. Okay. Assuming this is a relay race, the entire team must score between 225 to win the tournament. Is this likely? So if I do my normal CDF or normal distribution, and I go 229, comma 4.66. And there's my normal distribution of that. If they get below 225, so they have a 19.5% probability of that happening, so that's number 8. And if Isaac runs the race, that is well below the normal because it's raining. Explain why this violates independence, the assumption. Because all of our times were taken in dry conditions, normal conditions. The reason why it is goofy is because it's raining out. Okay? All right. So 3-9, combining distributions. And my phone is blowing up. Who is texting me this early in the morning? Oh, no. Yeah. All right. So I'm on page 83. Oops. And here we go. Last Monday lecture. All right, this is the last of the new material. So when we have observations from two normal distributions and add the results, you obtain methods calculating the mean, standard deviations, and combined. So one instance presented here, recall there are two bowlers. So you had bowler A, who had a mean of 140 and a standard deviation of 15. And you had bowler B with a mean of 100 and standard deviation 20. Okay, let's assume the bowlers are to bowl one game. We want to know the percentage that that bowler B will score higher. So B will have a better score than A. Okay, so by looking at it, it appears that bowler A is the better bowler, but we want to know the probability that B will do better than A. Okay, so it's pretty unlikely, but it's not impossible. Bowler A has average substantially higher than bowler B. We can represent this probability as bowler B is greater than bowler A, or B is greater than A. Or we could also do B minus A is greater than 0. So basically just using algebra but subtracting A. That is, we have restated the question. The chance that we will obtain a positive number is if we subtract bowler B's score from bowler A's score. So we need to know what the mean and standard deviations of the distribution that results from subtracting B from A. The mean, again, is very predictable, straightforward. So we would say bowler B score minus bowler A score. And we're going to get negative 40 there. Okay, so the variances always add. Deviations are like errors. Each time that you have an opportunity for an error, this adds to create a larger error. Example for chemistry is that when you have a thermometer and the beaker and scale, each instrument will create error, and the errors always accumulate regardless of what the researcher is doing with the numbers. You never subtract the standard deviations and variances. Okay, so in order to find their standard deviation, it's going to be 20 squared plus 15 squared, which is going to come out to 25. Okay, so this is the combination standard deviation. And then now that we have obtained the mean and standard deviation of A minus B distributions, we can answer the question for the assignment. What is the chance that bowler B will score higher than bowler A? Or rephrase, what is the chance that B minus A, the distribution, be greater than 0? Normal curve can be done, and so we can just do this pretty simple. Our buddy Desmos, get rid of this, get rid of this, get rid of this. Normal distribution. And we had we had negative 40, comma, 25. So we take a look at that. This is what our normal distribution is. So what is the probability that this is less than 0? So I'm going to go 0 to infinity. So it looks like there's a 5.5% chance that our bowler B will do worse than bowler A. Okay. You can expand this number of ways. So if you expanded it, it's going to be the same kind of concept. So let's just give you guys the opportunity to try this. So we are on 3.8 or 3.9, excuse me, 3.9. All right, let's do this. Give you the opportunity to work on this in class. So page 193 and 194. Yeah, the remainder of the period. So about a couple 16 minutes or so. Start on that, see how you do. Cool? And I can help you if you have questions. Let me just get rid of that.